277. It's good. That's good that we're doing these because like it is an exercise and we'll just get better and better at it. Letter B, Nate.
$2.
$2 because $1 is 4 quarters, right? And we double that to get 8, so $2. Good. Letter C, the top of that new fraction when we renamed is what, Matthew?
20.
20, because 6 times 4 is 24. 5 times 4 is 20. Reduce 12/20, Samanian.
3/5.
3/5, because 4 goes in there 3 times and goes in there 25 times. Letter E, squaring.
I know.
You ready, Josh?
25.
Okay, 9 plus 16, yes, 25. Winner, winner. Okay, F.
You do 6 plus 8.
No, I did 9.
Amy.
Yes.
You ready for letter F?
Is that 12?
Okay, so if we take 30 and divide it into 5 groups, we get
What
6. Yes, it is 12.
Oh.
Did I scare you? It is
Yes.
12, yes. Good job. We're going to talk about the metric system. The metric system's easy as long as you understand how to move between them. I want to hit this hard because I have some algebra students and higher that don't quite get the metric system, and so I'm going to teach it to you the way I learned it when I was younger, and I love it. And so we're, again, right there in the box, it just tells you, it's hard to memorize this kind of stuff. All right, 10 millimeters is 1 centimeter, blah, blah, blah. Like, do any of you carry around this chart in your mind?
No.
I don't. I would never know how to do that. So let's figure out how to create a chart. So once you learn King Henry died unusually drinking chocolate milk, converting between these things is going to be like a piece of cake. Okay? Not really, I don't have any cake, but there it is. So I'm going to get rid of this visual up here. So obviously this is an acronym. And what we do is we make a chart out of it. But I want you to look at it as you go. There's stuff, so K, H, D. King Henry died, usually drinking chocolate milk. Whenever I had a test and I had to convert between decimals or change decimals, I wrote this thing. And I wrote it like this. We go, just a grid. And the answer to every decimal question is in this grid. It's actually quite beautiful. But these all stand for something that you might not know. There's 3 that you use a lot. 3 of these that you use a lot. This is units. So if we're dealing with like meters, you might have meters, you might have, what else? Meters is length. Liters. Liters is volume.
Grams.
Grams, yes. Grams are for mass. Weight. Mass, yes. Good question. Units. So yeah, that's where I have units. So we're dealing mainly with meters, liters, and grams. Okay? So anytime this works for all 3 of those. Now you're used to this thing. If we're doing meters, this would be centimeters. What would this be? Millimeters. Okay, what would this be way over here?
Let's see, kilometers?
Kilometers.
Kilometers.
Yeah. So you've seen. Now, did you know there's stuff in between? I didn't. We rarely use them, but it's good to know they're there. Because they take up a spot. So let's just look at this for a minute. If I had 10 meters, how many centimeters do I have?
What?
Huh?
What?
How many centimeters are in 10 meters?
Centimeters.
So we're going to move them this way.
1,000.
10 meters should have more centimeters than you do meters, right? Because there's a bunch of centimeters in a meter. How many centimeters are in a meter, do you know?
100.
100.
What
So-
Matthew said.
So if we have 10 meters is 100 decimeters, is a 1,000 centimeters is 10,000 millimeters.
That's a lot of millimeters.
Okay? And how many that's decameters. That's where we do 1.1, 0.01. So, let's go ahead and turn the page and put this into practice. I also give you a couple of things. Sometimes we have to know how the metric system compares to the U.S. customary system. So sometimes you do need to know how many inches are in or how many centimeters are in an inch. Okay, so it's good to remember this one. That's going to come up a lot in algebra. 1 inch is 2.54 centimeters.
What?
So it takes about 2.54 centimeters to fill in an inch. Okay? 1 meter is about 3 inches longer than a yard. Example 1, 5 kilometers. This is where, if I were taking a test or doing homework, I'm going to write this little grid. Here's my grid. And I use it all the time. 5 kilometers. So I'm going to write 5 here. You guys go ahead and I want you to draw the grid. Under letter A. Of example 1. 5 kilometers. So you put what we're starting with, and we're going to convert it to meters. 5. And where does meters? Will be where the U is, right? Because this is kilometers, hectometers, decameters, meters, decimeters, centimeters, millimeters.
Yeah.
So that's what you got to think.
Okay.
There's going to be a bunch of meters in there. So there are 50 hectometers. Again, these don't matter. You don't even need to remember hecta or deca. But it'd be good because you're only going to get older and you're only going to go farther in science. So how many meters are in a 5,000 meters? Yes. Okay. So now let's take 300 centimeters. Remember, chocolate for anyone who finds a mistake when I do it. But now I have the book out, so I'm going to check myself before I wreck myself. 300 centimeters. I'm going to put that over here. 300 centimeters.
That's 3,000.
Hey, you get a chocolate.
Is how many meters? Did I write?
Hey, he gets chocolate.
300 centimeters. Okay. Write your name on the board, but this is the good spot. Up there, bad. Go ahead, write your name. This is chocolate. This is the chocolate box. Okay. Chocolate, naughty. Chocolate, no chocolate. So 300 centimeters is how many meters? Okay, here's meters. He needs to move over here. How many meters are in a centimeter? How many centimeters are in a meter? Yes.
I know the answer.
Oh, you do know. So what is it in your mind that helps you go from here to here, whether or not you drop zeros or add zeros?
I actually just know.
Oh, because you know there are 100 centimeters in a meter. Yes. So, you can tell me the answer.
3 meters.
3, yes. So there are 30 decimeters and 300 centimeters is 3 meters. Okay. A 2-liter bottle can hold how many milliliters? Now we're doing liters.
Oh,
Now we're doing volume. Huh?
Drawer.
Do another grid.
Okay.
In fact, if Mrs. Everett was here, I would ask her if she is a supporter of the grid or non-supporter. I'm just curious.
She's probably not memorized.
Yeah. The grid is good for those of us who might not just naturally think this way. Okay, 2-liter bottle. So where does 2 go? On unusually, right? There's the
Here.
liters, 2 liters. How many milliliters? What goes in there? Well, we're gonna have more over here, right? So what did you get, McKenna?
I got 2,000.
2,000, yes.
That's what I got.
Good job. And again, if we plug it in, it'd be 20, 200, 2,000. Okay. How many 250 milligram tablets of vitamin C equal 1 gram of vitamin C? How many milligrams do we have? Yes,
1,000.
1,000 milligrams. So we're going to take 1,000 and divide it into 250 milligram tablets. So you couldn't do 1 gram divided by 250 milligrams. Do you know why?
Because it would be the same.
They're not, they're not the same units. You can't just divide 2 different units. So we have to convert them into milligrams to divide by milligrams. Does that make sense? You can't do any cross division on that one. So then we get to that. And then think about the 25 cents.
Yeah, you have to take out the 0.
Yes, we get to take out the 0
And it's 25.
into 100.
Yeah. Good.
Is
Four
how
times.
many? 4 times. So you can do 4, we call them tablets. Tablets.
Of vitamins.
I'm just going to say 4 tablets. You could even say tabs, because I think they say that in Dr. World. Okay, not Calvin. Kelvin. Someone's last name. Celsius, I always want to go back and check and see what the Latin root is, because it's U.S., so I'm pretty sure it's probably from the Latin root. Now, since we throw this in with the study of the metric system because they are both base 10 scales. Celsius and Kelvin are scales scientists use to measure temperature. Both are centigrade scales, meaning there are 100 degrees or gradations between the freezing and the boiling point. Both of them just mean here's freezing and here's boiling, and there's 100 degrees in between. Is that the same as Fahrenheit? What's Fahrenheit? How many degrees are between freezing and boiling in Fahrenheit? Anyone?
Oh, it's like
There is on your 212 minus 32. 212 is boiling.
Yeah,
32.
180.
180.
Yes.
Yes. I said
So
first.
180.
Actually,
Again, the U.S. uses stuff that is like nonsense. Can't we just do 100, base 100? Everything is so much easier, right? So let's read about that. The Celsius scale places 0 degrees at the freezing point of water because water is the most probably common liquid, right, that we see. Kelvin does not place 0 at the boiling or the freezing point of water. They call it, Kelvin places 0 degrees at absolute 0. Do you know what absolute 0? And it's at negative 273 degrees. So it's cold.
Isn't it
Like there's freezing and then there's, yes.
Extreme.
Absolute 0 is when everything stops. It means any sort of molecular vibration or movement is gone. Nothing.
That's crazy.
That's
Okay.
scary.
Everything. It is scary. You're dead. So that's what absolute 0 is. That's why it would be good because Mrs. Everett probably has a much better grasp of absolute 0 and what that means when it comes to the periodic table and chemicals and stuff. But I'm just, I'm a little bit more limited in that. Right, the Celsius scale is more commonly used by the general population, right, except in the U.S. Here we've got some good temperature scales. We know like right now, what is it, about like 60 something degrees outside? Absolute 0 is at negative 459 degrees. To what?
Oh my goodness.
That's
Yeah.
crazy.
It is, so it's cool. So now we're going to ask, here's a tricky question. A temperature increase of 100 degrees on the Celsius scale is an increase of how many degrees in the Fahrenheit scale? We actually just did this. Okay, look at number 4. A temperature increase of 100 degrees.
What?
A temperature increase of 100 degrees is, what's it say?
Not.
Is how many in Fahrenheit? Yeah, do you have your hand up?
Yeah, 212.
Almost. It's not what's the boiling point. They're saying the increase. The change from a change of 100 degrees in Celsius is what kind of change in Fahrenheit? Well, if this was 0 and this was 100, in Fahrenheit it's 32 and 212. So we kind of just answered this already, didn't we? What's the change? Here it was 100, here it is 180. Do you guys remember that?
Yeah.
So that's the answer, is 180 degrees. Okay, so I want you to look on the practice and look at number D, letter D. A temperature increase of 10 degrees in Celsius is how many in Fahrenheit?
Oh, it's 18. It was, so 100 degrees was
Oh, he's right.
180.
I know.
Wow, nice.
You guys see the big brain on that guy right now? You see that?
And he got 100% on that.
Oh, and he got 100% on his math test. Okay, he said, well, if this is true, then if we go up by 10 degrees, then how much do we go up here? And he said, how many? 18. Because he said, oh, well, 100 divided by 10 is 10. So 180 divided by 10 is 18. So the answer to letter D, thanks to Mr. Big Brain, and then Nate caught it right away. He's like, oh yeah, he's totally right, because he was right there with him, is 18 degrees. Okay, probably the hardest question in the practice. What time do we get out?
You're
We're done.